and so on. So let's look a little bit. It's about the biology of being human. Where is it in the wide field of knowledge we all have to have when we deal with the human brain? The brain functionality is actually impacted by many different factors. One of these factors, of course, is the structural damage. Hardware issues, concussion, TBI, tumor, injuries, and surgery. It's like if we talk about the computer is damaged if we have a brain injury. But there are other factors. There are the supply issues, which we know very well, thanks to you, Richard, Rob, and James, which affect the brain's function not through a structural damage, but rather through a supply damage. And the third thing is there are data storage issues. The computer is running fine, the supply is there, but the data the computer calculates with are somehow mixed up. That's more the field of psychology and psychiatry. And then we have the great field of environmental issues, toxicity, climatic, social, which jolt the human being out of its originally, or according to the blueprint, designed field of life. And electromagnetics is one of these topics. It has a great impact on the environment. It has an impact on the supply and issue side, and it also has a long-term effect, of course, on the structural functioning of the brain and on its data processing capacity. So what we are talking about here is a very fundamental environmental topic. Now, electromagnetics also impact directly the brain function, as we will see later, and of course the technique of neurofeedback and brain mapping. Nobody should ever start a presentation without showing the face of this gentleman here. He said, electromagnetic energy is the foundation of everything. It is probably the fundamental life energy. So let's look a little bit at what we can find out about this today. The presentation has actually three themes. The topic number one, well, that requires quick action, sorry. The topic number one is we look at what we know about electromagnetics today. Topic number two, we will have a look a little bit at the electromagnetics in biology. And the last topic, probably the most practical and interesting, would be we look at electromagnetics at our offices. Let's dive right into it. What do we know today? Let's have a brief overview over the history of discovery of electromagnetics. Then we go into theoretical part, look at what we know about the electromagnetic wave, and also, of course, at the interplays of electromagnetic waves with each other and with materials. So let's go to the history of this discovery. It goes back to the second half of the 17th century, the times of Isaac Newton and Johann Sebastian Bach. There was a gentleman called Otto von Guericke. He actually discovered that when he would put an electrical current on two wires, they would depart from each other. So he actually founded and scientifically documented the concept of an energy which works at distance. About 100 years later, another pair of gentlemen made fantastic discoveries. The names are known to all of you. It's Luigi Galvani in Bologna, Italy, and his close friend Alessandro Volta. Galvani was actually experimenting with the means of electricity he had available there, and putting wires onto frog legs, sparking them, and the legs would jerk. This caused his friend Alessandro Volta to go deeper into it, and he was actually the discoverer of the battery. So at that time, in the later part of the 18th century, an age started which was very decisive for the further process. It's the DC age. From that moment on, in the field of electricity, there was actually a source for electricity, which previously could only be produced by rubbing glass or with Leyden jars. On the other side, we have the side of magnetism in electromagnetics. And a very fundamental discovery was made by a French gentleman. He was called André-Marie Ampère. He was actually an engineer, and he discovered that magnetic forces deprive with the square of the distance. They become weaker with the square of the distance, the famous law of Coulomb. Those two theories and findings, still in the experimental way of electromagnetics, actually ended up with André-Marie Ampère, who in the early decades of the 19th century practically and theoretically discovered or defined electromagnetics. This part of history is extremely dense. Ampère was followed by Michael Faraday, who discovered in England electrolysis. He actually discovered the electromagnetic induction and many other laws in connection with electromagnetics. But actually the big one, the really big guy in electromagnetics is, of course, James Clerk Maxwell, who finally made a connection between electromagnetic and light. He also found out that electromagnetic waves travel at the speed of light. He made the connection between electricity, electromagnetics, and light. And then I must say I must give credit also to a gentleman we all know well from the brain mapping, which is Mr. Gauss. Gauss was an extremely, probably the best mathematician, at least of the 19th century, and he discovered, apart from statistics, many other things. Gauss and Maxwell together, they have formulated whatever we know today about electromagnetics. A little bit later in that century, towards the end, there was another gentleman which probably sounds familiar too. It's Heinrich Rudolf Hertz. Up to here, still in the DC age, the only source of electricity was batteries. Up to here, electricity was still kind of a riddle, even though mathematically it was kind of clear now with Maxwell. But Heinrich Hertz actually started to produce devices which could produce electricity and electromagnetic waves. So he launched a totally new era. It's the AC age. And in this area, a lot of things happened. Immediately, the first thing after Heinrich Hertz's theories and apparatuses were published was an enormous field of application technology opened up. And with Nikola Tesla at the end of the 19th century, the production of AC energy actually started. And this launched a real avalanche. Right after early decades of the 20th century, power grids were installed, which enabled a lot of technologies to be developed in labs. One of the earliest ones was the imaging technologies with X-ray. Radio technology became very prominent at the very first decade of the 20th century, and later, towards the mid of the 20th century, nuclear technology, electronics, and the last gadget, laser. So up to here, electromagnetics was a DC-oriented and basically mathematical appearance, which diverted directly into quantum physics up to today. The rest we know about electricity and electromagnetics is basically application technology. In the mid-19th century, medical science started to evolve. Today's medical science, however, is completely and almost exclusively only dealing with application technology. And that leads us to imaging, X-ray, electron microscope, and in the latest years here to the whole scanning and fMRI techniques. So when it comes to electromagnetics, the medical science is not involved. It's the involvement of the medical science is electromagnetic application technology. However, there is this little group of neurofeedback specialists and brain fans, and they're on a completely different line, diverting directly back in the late 18th century to Galvani. Galvani was the only medical doctor involved in this whole development process up to here. All the others were engineers, physicists, and mathematicians. Galvani, however, was dealing around with his frog legs. And this led in a very straight line to the discovering of Cater, who drilled holes into the skulls of cats and dogs and inserted wires and found out that brains produce electricity, still in the DC age. And then it led in a straight line to Hans Berger's EEG discovery. It went on across the line through a couple of very important steps we have here. This little dot here represents Mr. Barry Sturman. And this, the next dot here, includes people like you, Richard, where people started to make a statistical research and establish brain mapping, also banks, data banks. And the very latest and quite interesting gentleman, in this chain is actually a Dr. Bruce Lipton, who discovered the impact of electromagnetic fields and energy on cellular functioning. He actually started a science which is called bioelectromagnetics. In this whole field here, even us, there is one thing which strikes me odd. Nobody ever thinks about or talks about why the brain produces electrical waves. All we do is we're measuring them and comparing them. So very, very recently only, a very new scientific field starts, which actually deals with biologically produced electricity in organisms. That explains that difference, or the historical difference explains why we sometimes have troubles with these guys here in terms of understanding each other. We're the only ones who actually deal with human-produced electromagnetics. So far to the history. Now, I want to show you something. I overlay a statistic here of the global population. And as we will see in the progress of the presentation, that is one of the major health issues and problems we face with, because these are all users of man-made electromagnetic pollution. But now let's get on. Let's look a little bit at the electromagnetic wave. The electromagnetic wave is so complex that most of us will have no chance to actually imagine, visualize how it works. All we see now is also the result of mathematical calculations, not of experimental observations. So the electromagnetic wave has, as the name says, an electrical component which fluctuates between electrically charged positive and electrically charged negative. Superimposed on that is a perpendicular magnetic wave. With the same frequency, it fluctuates between magnetic north and magnetic south. Together, that thing looks like that. So we have in one direction, an electrical charge which oscillates between plus and minus, and in the other direction, a magnetic charge, 90 degrees angle between the two, which fluctuates between north and south and propagates in this direction. Characteristics of an electromagnetic wave are the speed. All electromagnetic waves travel with the speed of light. The speed of light in vacuum is defined by 299,792,458 meters per second, about 180,000 miles per second. The travel distance of this wave is unlimited. Characteristics of the wave of this wave is the frequency, or cycles per second, named by Mr. Hertz. And one thing which most people don't know, correlated with the frequency is an electromagnetic energy, which is measured in electron volt. Reciprocal to the frequency is the wavelength. The higher the frequency, the shorter becomes the wavelength. We will see that this has great implications when we come later to the biological side of electromagnetics. One very important thing is that electromagnetics, like all other waves, always interplay. We have several ways of interplay. We have the interference. Interference means if two of these little structures here meet each other, they add up their amplitudes. If one is plus and the other one is also plus in the electrical field, the plus will double. The same applies to the magnetic field. We have another appearance with electromagnetic waves. When they hit material, they might change direction and speed. They might even be absorbed, which means the material transforms electromagnetic waves into other forms of energies, for instance heat. Electromagnetic waves, however, they have a very special characteristic which other forms of energies don't have. Namely, the characteristic of induction. When an electromagnetic wave hits a conducting material, it triggers in that material an electric current and its own electromagnetic waves. It also can cause that material to resonate, which means to produce its own frequency, a different frequency of electromagnetic waves. One thing which is often mixed up with these interplay characteristics is a term called coherence. Coherence is not an interplay characteristic, but it's a comparison of how different waves behave in terms of frequency, amplitude, and so on, phase. So these are terms which most of us have heard, but I'd just like to recall them quickly so we understand a little bit better what's going on with the next step. For us here, one thing is extremely important to remember and keep in mind all the time. Electromagnetic waves are invisible, don't sound, don't smell, cannot be touched, and cannot be felt. But electromagnetic waves are always there and everywhere. That's all we know about how electromagnetic waves look today. The whole knowledge about electromagnetics actually is based on Maxwell's equations, where good Mr. Gauss, our statistical genie, has very much attributed to. I don't stay here. I don't think anybody is interested in going into details with this theoretical stuff. Let's get a little bit closer. Let's go to part 2, the electromagnetic biology. There's 5 topics I would quickly like to touch here. The natural electromagnetic universe, electromagnetic environment and cells, the brain and the body, and the kind of impacting theme of man-made electro smoke. So let's dive into it. I love this one. Most people are completely unaware that out there is an extremely complex, infinitely large world of electromagnetic music. The main players in this concert are, of course, as we all know, the Sun and our planet, of which we are not inhabitants, but at least in electromagnetic terms, definitely part. In between, there are a lot of other players which play an absolutely vital role. We have all the living organisms, which do not only produce brainwaves, but all sort of muscle-induced electricity on a larger scale. Around them, we have the atmosphere with weather, which is an extremely strong producer of electromagnetic waves. But there is the other world too. There is the micro world, and each and every player in that world, from cells, crystals, large molecules, down to simple atoms, they all produce electromagnetic waves. And they all have their specific range of frequencies. Down here, we see the frequency band. Let's look quickly at the planet Earth. One of the driving electrical pulses of the planet Earth is in the range of 7.8 Hertz. It's the famous Schumann resonance. It's a pulse which, through its wavelengths, actually it's produced by the planet itself. Nobody knows exactly how this works, but the planet Earth has a heartbeat of 7.8 Hertz. Note the closeness to the difference between alpha, or the boundary between alpha and theta waves in the brain, the human brain. That pulse has wavelengths which makes it coherent with the circumference of the planet in a frequency which is actually mirrored by the ionosphere here, a protective layer of molecules, so that it produces a standing wave and a grid, a very specific electromagnetic grid about the planet. This is of a fundamental importance because it's one of the driving forces of all chemical reactions. Also, I would like to draw your attention very quickly to the fact that we have these small little players here, which are all defined by their size and the size of their atoms they're consisting of. Players in a very high frequency, microwave frequency range up to light, and even into the radioactive ionizing frequency ranges here. So there is a field, there is a harmonious, enormous concert, a symphony of continuously changing electromagnetic natural players out there which actually define life. Remember Albert Einstein. Let's look at electromagnetics. Can I say it? Let's look at electromagnetics and the body. Sorry, this poor lady here is kind of peeled. I chose the picture just for optical reasons, for the color. The human body, through its structure, is a highly conductive, complex antenna. Whenever this natural electromagnetic field here, a concert here, encounters the body, and it does so constantly, it continuously keeps on inducing electricity in the body and electromagnetic waves, and it causes very specific resonance fields within the body. As a matter of fact, there are only so many possible designs of organisms available because of that interference with, or of interplay with the natural electromagnetic environment. Certain forms can't exist. They would fall apart because the electromagnetic waves around them, the concert around them, wouldn't allow them to biochemically be stable. However, in a macro perspective, the human body is a giant antenna. It picks up everything which goes on electromagnetically outside. It also produces electromagnetic waves. And it's a part of that huge symphony here, the symphony orchestra of electromagnetic environment. If we go to the brain, as we know very well, the brain is an extremely powerful electromagnetic transceiver. It not only receives electromagnetic waves, it also produces them. Now, the brain has the job to keep that body functioning, and one part of its means to do so are electrical signals. And there is no electricity without with magnetism. So the brain, of course, works with electromagnetic waves. However, in order to do so, he has to continuously consider environmental electromagnetic waves which interfere with its own production. And he also has to consider the body electromagnetics which are actually induced by the environment, as we have seen before. On a much smaller level, when it comes to our human body, there is a lot of things going on in electromagnetic terms. Recently, Dr. Bruce Lipton, a cell biologist who used to train medical students in cell biology and genetics, discovered that the cell membranes actually internally regulate mitochondrial activity, activate respective parts of DNA, and contribute to the contraction or dilatation of the DNA molecule, all induced by the electromagnetic environment around the cell membrane. Electromagnetic environment in the body around the cells is an environmental factor which cells membranes use to regulate their functions. So we see that actually Albert Einstein wasn't all that wrong when he said that electromagnetics really are a fundamental life energy. Now comes Homo sapiens, marching in. Since about 100 years, we are playing around with electrical devices, causing an enormous cacophony of noise in that harmonious, fine-tuned, natural electromagnetic environment. This is what we do. In the background, you see that symphony again, which is the natural, invisible electromagnetic universe. We're interfering in the low frequency range with electric technology. Electric technology is anything which runs on electricity, from trains, high voltage line, kitchen appliances, your printer, whatever, any fan and motor produces a lot of very strong electromagnetic radiation. Of course, this is just garbage. We don't need the electromagnetic radiation. We just want the power of the electricity. However, because of laws of nature, it's unavoidable that we create an enormous noise in the natural harmony with these electromagnetic waves. Sorry. Equally, where are we? Here. Next. I apologize. Equally and way more destructive is the recent development of microwave technology. Why did we develop this technology? Because technology is developed by engineers, technicians. They have no clue of the natural electromagnetic environment. So they chose the bandwidth which was the most practicable. In the lower ranges here, there is a lot of interference. So many of us remember the radio times when a thunderstorm actually made it virtually impossible to listen to radio, or would distort even TV pictures in the early stages. This energy is very strong. There is disturbance here, natural disturbance. However, in this range here, in the frequency range in the gigahertz, terahertz, in this range, there is seemingly no disturbance, as if nature would produce a bandwidth which is not used. So that's where the technology now goes. These microwaves here, they have another advantage. They go through walls, they go through most metals, they travel through material. So they're ideal for communication technology as data carrier frequencies. Of course, the whole engineering department of humankind completely ignores the fact that this is the playground where in the natural orchestra, where we are in the cellular and in the molecular range of radio waves, of electromagnetic waves. And now we know they have to, it's a law of nature, all waves have to interfere with each other, they have to resonate, it's law of nature. So that's where we're producing the number one noise nowadays. We're also producing a noise in a higher frequency range. This is the artificial lighting. And of course we use the technology for imaging and nuclear technology. Man-made electro smoke is also completely invisible. It doesn't sound, it doesn't smell, it cannot be touched, and it cannot be felt, but it sure is there. So, does it affect us? Unfortunately, it must. It's physics, it's law of nature. How does it affect us? It affects mood. How this happens, we will see in a moment. It triggers change of genetic information through the fact that it changes the environment of our cells and thus influences what part of the DNA codes are actually activated and what not. Experiments have shown, I apologize, let me quickly switch off the phone. Yeah. Experiments in Germany have shown that, and it has been a very good study. It was very seriously made. That electromagnetic waves disrupt, particularly in the microwave range, disrupt the blood-brain barrier in rats. Again, one of the mechanisms could be that they change critically the environment of the cells which are involved in the blood-brain barrier. Those rats had serious health issues after being exposed. The experiment was actually banned by a court decision which decided on the grounds that experiments on rats cannot be one-to-one transferred into human symptoms. Then electromagnetic waves, particularly again in the microwave range, excite every single water molecule in the body. This does not only change temperature of the thermic processes, but it disrupts the biochemistry. Electromagnetic radiation in the high microwave range supports heavy metal toxicity. All these points we will look into a little bit more detailed right away. And, of course, electromagnetic radiation interferes with brain waves. It does affect you. It must. It's physics. Here is an experiment which I participated in 2006. We had it was a total of 40 participants in this experiment, and all we did is we made a dark field photography of health of erythrocytes, red blood cells, had the participants make a phone call with a cell phone 2006, which had about a third of the broadcasting power of a modern iPhone, and measured, had a look at their erythrocytes again with a dark field photography method after a 4-minute cell phone call. And that's what happened. These are the healthy cells. Remark, they are round shapes, circular shapes, free-floating. And after those 4 minutes, they showed extreme signs of stress. You see how they stick together, form those little pillars of things. It's a symptom which we see in suffocation. It's an extreme cellular stress. 4-minute cell phone caused this blood to look like that. 40 participants, none had a normal blood picture after 4 minutes cell phone call. Again, 2006, and I participated in this experiment. We were not allowed to publish it on grounds that we didn't check, we couldn't prove that no other factors, no other electromagnetic factors like microwave ovens or so were contributing to that factor. It is very dramatic, and it's measurable. Another factor which man-made electro smoke can imply is a vitamin B thing. Vitamin B appears on almost every brain map I have made so far as one of the suggested supplements. Vitamin B has a very rare element, cobalt, in a very special kind of binding here in the middle. Cobalt, it's an ion in this particular complex here, is actually bound to the nitrogen atoms here. It has one electron bound, they share one electron, all the others are actually electrical bounds here. See that? Cobalt has is ferromagnetic, that means it's magnetic like iron, and it has an electronegativity, the force it can maintain its outer shell electrons of 1.88. Now we hit that fragile molecule here with high frequency electromagnetic energy. It will excite this cobalt atom here twice. It's the magnetic component which makes it shake and trickle, and it's the electric component which makes it shake and trickle. This here can be chunked off the vitamin B molecule very, very easily with little energy. What happens then is it's very likely to be replaced by other molecules swimming around. And the favorites are copper, with a similar electronegativity, which is diamagnetic, so it will not be excited by the magnetic component of the electromagnetic wave. Lead is another one, very similar electronegativity to cobalt, with its diamagnetic, non-magnetic as well. We have zinc. It has even a lesser electromagnetic component than cobalt. Aluminium, calcium, even sodium could easily replace the cobalt. During the process of breaking up, both of them become free radicals. The cobalt will be positively charged, attracting change in other chemical components, while the rest of the vitamin B, which of course without the cobalt isn't a vitamin B any longer, is negatively charged during the breakup process. So that's one of the effects which can easily be created by electromagnetic radiation on a micro level. Let's go to the last part of the presentation here, which is the electromagnetic office. And we look at the artifact electro smoke, the low frequency pollution and what to do against it, and the high frequency pollution, what to do against it. And at the end, we look how an ideal neurofeedback office, where we can do clean brain maps, should look. There are the two fields which are actually the primary concern. We have the low frequency pollution produced by all the electricity in our office. And we have the high frequency pollution, which is produced by the wireless technology like Wi-Fi, our gadgets and toys, iPhone, tablets and stuff, wireless printers. So let's look at them. First of all, the pollution degree of your office can easily be measured. There are devices which measure the field strengths, two different devices specifically designed for low frequency pollution or high frequency pollution. The low frequency pollution is produced by the power grid and all electrical devices. Its problem, its main issue, is the low frequency. It directly interferes with the electromagnetic and electrical activity of the central nervous system. Another issue is frequencies up to about 300 hertz, electromagnetic waves up to 300 hertz can travel in liquids, particularly in saline liquids. So through the circulatory system, the low frequency energy, the low frequency waves can actually penetrate the body, even so the body's insulation capacity would be quite big, would it have to traverse skin and bones. But through the blood, it can distribute in the whole body. Low frequency pollution is in the range, in North America, in the range of 60 hertz. 60 hertz are the gamma range. Not only its harmonics, but the gamma range, as we know well, is also impacting, of course, the theta range quite considerably. So the problems are, it's conducted by watery solutions like blood around the body. It creates complex induction by doing so within your client and, of course, within yourself as well. It interferes with the brain directly, electromagnetically, with the brain waves. It resonates best with its harmonics, half the frequency, 30 hertz, half of that, 15 hertz, half of that, 7.5 hertz, and half of that, 3.75 hertz. So delta, high delta, the boundary between theta and alpha, low beta, and high beta waves are also impacted with the power grid if you switch on your 60 hertz notch filter. That has absolutely no influence on what's going on within the body. The notch filter only filters out the signals which come from your electrodes. It doesn't filter out, or it has no impact on what happens within the body of the client we have hooked up. Remember, the human body is a perfect antenna for this frequency here. And the skin is a perfect surface conductor for this frequency range again. So it's virtually impossible in a low power grid electromagnetic environment to read an EEG. It will always be artifacted with the power grid. What can you do? How can you protect yourself? First of all, the location of your office is of vital importance. Even so, this outlook might look romantic in the eyes of certain people, this is definitely not a healthy neighborhood. A safe distance, safe meaning that you have a fair chance to really get the true brain waves in your office. You have to have a distance of at least 500 yards from a high voltage power line. In many, particularly suburban or rural areas, electricity is transported free hanging and free lines, and on the posts you have those reduction transformers, these boxes, which are normally quite near the room you would be working in. You need at least 15 yards distance from such a box in all directions. Even if there is a drywall between you and that box, it doesn't shield off the electromagnetic waves coming from that transformer. Further, all devices which are in any way connected to the power grid actually are transmitters of 60 Hertz electromagnetic waves. That includes printers, computers, desk lamps, halogen and dimmable lighting, fans, air conditioners, power bars, power outlets, light switches, and any live cable, even if the device is switched off with the power switch. So all these things here, which are lying around in an office, they are additionally producing, they're additional broadcasting antennas for the 60 Hertz low frequency electromagnetic waves. Remember, they don't stink, they don't smell, you don't see them, you don't feel them, but they are sure there. So, the things you cannot switch off and plug off are fixed installations like light switches and power outlets. Make sure any part of equipment and any body part of your client is at least 4 feet away from any of these fixed installations. Of course, electromagnetic waves travel further than 4 feet, but with Coulomb's law, the square of the distance reduces the field strength. Coulomb's law says that with a distance of about 4 feet, the field strength of those electromagnetic noises of the pollution, the electro smoke, is so small that the body easily can overpower it, and you probably will not be able to have a great impact on the EEG. 4 feet, that's a good figure to remember. However, the big problem and the increasingly bigger issue is the high frequency pollution produced by wireless, Bluetooth, laser and lighting. And the main issue of the high frequency, also high energy and high shortwave, is its extreme penetration capacity. It can go through everything. It's specifically designed to travel through material. So you can have a Wi-Fi system in your office which the signals travel through walls, or you can use your cell phone in a car. It was specifically designed to penetrate. Now it's not, if those waves travel through car skins and walls, they easily travel through the body. The other main issue is it doesn't affect primarily any part of your body which you would have any conscious access to. It works on the micro level. It affects organisms and cellular and molecular structures. High frequency pollution produced by wireless, Bluetooth, lighting and laser breaks through with absolutely no effort all body's insulation systems. Wherever they are, inside the body, outside the body, they excite water molecules, as we know from the microwave oven, which operates in exactly the same frequency as your tablet, your frequency band as your tablet, your cell phone, your Wi-Fi, and your Bluetooth devices. So, now, question here, people are talking about carbon dioxide being a main cause of global warming, while everybody is walking around with little microwave ovens, which broadcast all the time, and not only excite water molecules in the body of the carrier, but also in the air around them. This just as a side note. It takes 1 minute to heat a glass of water in a microwave oven. Your cell phone heats water in your body, in your brain. It causes, through the toxicity we have seen with the vitamin B before, it causes an enormous metabolic stress and toxic stress, which of course also affects what you see on the EEG. It facilitates toxicity, heavy metal toxicity, as we have seen before. And it interferes with many biochemical mechanisms, such as by actually changing the electromagnetic environment of cells, thus having an impact on how that cells regulates its own metabolism and what DNA parts are actually activated. So, unlike the low frequency pollution, which can be switched on and off, all you need to do is get away from the power lines and switch off your equipment. The high frequency pollution creates, through metabolic and biochemical effects, long-term effects on the EEG. Your client is stressed, and it's not a brain problem, it's a body problem. So, what can we do? Wireless devices, cellular antennas, your office should have a distance to the nearest one of 1 mile. Below that, the impact is measurable. Cordless phones, 300 feet. Wi-Fi stations, 200 feet. iPhones and tablets, 200 feet. Laptops with their Bluetooth or wireless broadcasting on, 200 feet. All Bluetooth devices, 30 feet. Bluetooth mice, Bluetooth keyboards, whatsoever. And one factor which must not be neglected, all CFLs and neon lighting have Tesla coils to excite the gas. So they also broadcast microwaves. And the distance, the safe distance in terms of electromagnetic waves would be 15 feet. However, there is another factor impacting us. It's the artificial light, which dysregulates, of course, our circadian rhythms with the very cold blue light. So, what's the safe distance to wireless and Bluetooth and microwaves? None. It's unsafe. Switch off what you can. There are 3 things to keep in mind. The impact decreases with the square of distance, Coulomb's law. Your device are the most impacting on you and your client. And the producer of guns, in this case the wireless industry, is not the killer. The user is. How does the ideal neurofeedback office look? Like this? Look at this gentleman's hand. Can you see what's under the table here? There is a power bar, and the distance is just about maybe 1 foot. Right beside the chair, you'll have a computer unit with a very powerful, can I say, transformer in it. You have the screen here with transformer. Look at the equipment which is hanging around here all over. And look at the cables running it out. I'm sure he gets a clean EEG reading with the notch filter on. However, the brain waves he is measuring, the brainwave component in what he is measuring is relatively small. In an office environment like this, you will never get the true brainwaves when you make a brain map. So how should the ideal office look then? That will be my choice. The cleaner you have your environment, the less man-made electromagnetic radiation is around, the greater your chance is you get to the true core, the biologically produced brainwaves. That's it. Thank you very much. We have reached the end, and if there is still time for some questions, please go ahead.
Martin, great. Thanks very much. That was a very thorough presentation. I like your office there. Foot traffic must be a little sparse, though.
Yes, it is. And probably, you know, the crux is in such an environment you have very little patience. Everybody's healthy.
That too, right? Well, we are out of time, but, you know, maybe we do 1 or 2 questions for people who want to hang on for a minute or two.
Yeah, Martin, that was excellent. I've got to run because I have a patient in the office, but great presentation. Are you going to make your PowerPoint available?
I'm producing as a PDF, and I make it available.
Perfect. You're going to send that along to me or Richard, one of us, and we'll get it up to other folks.
I'll send you a link where you can download it. That's the most easy way to do it.
All right. Perfect. Thanks again.
My pleasure, and I'll be around for a moment if somebody wants to discuss or have some questions.
Martin, that was terrific. I think I have questions, but there's no way they can be addressed. I have a patient outside there too. I think we need a follow-up of about a half hour on a lunch and learn where we could just talk about these issues for sure.
We can pick that up on Friday.
Would you like to do that on Friday? So I make sure you all get the PDF or at least the link for the PDF, so you can. Would that be of any use for you guys?
Yes.
Yeah, then let's do that. Richard, I'll definitely be there on Friday. So
okay.
I'm gladly open to questions.
Okay.
Hey, Martin, this is Honey.
Yeah, hi, Honey.
It was really so helpful. I mean, I've been trying to read books on this topic, and you really elucidated, really made it much easier for me to get a grasp on what we're talking about.
Oh, I'm very grateful and happy for your feedback. That's the purpose. Yeah. Thank you very much.
Thank you.
Okay. Well, Friday we'll pick up on this again, and maybe we'll go a little bit to the controversies, and Martin can address some of the controversies that are surround all of this, and how it may relate, and how also, you know, does it impact what we're doing? How might it impact? That would be some interesting questions, and we could bring up and discuss on Friday. So
absolutely. I mean, the focus probably should be on the low frequency thing, you know, because that's the most easy to understand. The high frequency impact is long term. Like the patient goes back home, has his cell phone beside the night table, right, and plays on his tablet until he falls asleep. Now, the impact, the electromagnetic impact on that is twofold. We already know the blue light effect of the screen, which has an impact on the circadian rhythm. but the metabolic impact, you know, the permanent exposure to your own devices so close by has really toxic effect. It's really disrupting the whole biochemistry. So it's not only it's the time and the density which are the key factors. It's not one single device doesn't kill you. But imagine Main Street at traffic hours, and everything except Wi-Fi devices becomes invisible, transparent. Can you see the density of little microwave ovens hanging around there? In every single car there is one. In the pocket of every pedestrian passing by there is one. The buildings left and right, they're full of Wi-Fi station, power, wireless printers, and it's just the density which is the real killer.
Okay, well, yes.
Martin, would those Kindles that people use to read books on also be a culprit?
No, that's a completely different. As long as you download the ebook.
Okay.
You know, anything which requires internet and doesn't have a cable, that is wireless.
Okay.
So, like for instance, if you have an iPad, but you do have some software on that iPad, and you can actually, go to the sixth underground floor in a parking, and you still can use your thing. There is no problem with communication there because the software is on your device. Like a laptop, where you have the software on your device, that is not a big issue. It does radiate in a small way, but as soon as you go online, wireless, then you have to use microwaves to transport the signals to the nearest Wi-Fi or cell tower, and that's the problem.
Thank you.
All right, I'm going to wrap it up here. We're getting pretty far past the hour. I hope everybody enjoyed the presentation, and we will follow up with all the controversies and more discussion on Friday. So come on back on Friday and find out the rest. Thank you very much, Mark. Take care.
I thank you for the occasion, and I hope I could give some useful information here.
Great. Thank you.
See you on Friday.